Wind power forecasting basically is able to forecast the amount of energy that a wind farm generates, and so that the load dispatch center is able to analyze and understand how much would be the power that your wind farm is going to generate. Now, if you look at wind power as an electrical parameter, it's basically the conversion of electricity out of the kinetic energy of wind that is blowing across a site. So wind being infirm, the amount of energy that this wind power project will be generating will also be infirm because of the very nature of the raw material that is used for converting the electricity out of wind. So therefore, whenever a project develops or generates a wind power, the regulator that is actually controlling the demand control scenario or the demand forecasting is unable to understand the amount of electricity that a renewable energy project, whether it's wind or solar, would be able to generate in next 24 hours, in next 48 hours, and or next 3 hours, whatever may be the scenario. So during the last 4 to 5 years, there was a demand from the load dispatch centers that whatever energy is being injected into the grid should be, the IPPs should be able to forecast it and should be able to send the 15-minute interval data to all the load dispatch centers so as to have a better demand forecasting management. And therefore, since 2010 onwards, the regulators on a central level started studying it, and after an elaborate study, the first regulation came up. But as usual, there were certain knowledge basis was less, the amount of IPPs that were readiness was not there, and therefore it took time for both the regulator and the industry to understand what exactly would be the forecasting, how it would be, and therefore the regulator now has come with a policy stating that the wind forecaster or the wind generator has to forecast the amount of energy that every project will generate on a 48-day ahead schedule scenario. So at the substation level. So all IPPs are getting prepared to do that, and it is as per the regulations, and there will be different bands that the regulator is asking the IPP producer to forecast in certain bands. And if the IPP is not able to produce in those particular bands, there of course there will be certain penalties that the forecaster, that the regulator will impose. To enable the IPPs or to the programmers who are doing the algorithms for a proper scheduling has to depend on a lot of inputs. It is the site data, the wind data, the weather forecasting data, the amount of temperature data, humidity data, because that all affects the amount of wind that blows across the site, and in turn it also determines the amount of energy that is going to be injected into the grid. There are also other factors such as the availability of the grid itself, availability of the machine, but that are okay, that are under control. But majorly which is not under control is the natural phenomenon of wind which is blowing. So India as such, the amount of forecasting stations that are available across the very remote sites, you see Satara site, even to going there has an issue, and the amount of infrastructure there has its own limitations, and therefore to predict a forecast in that particular geographically limited area was a huge challenge 3 years down the line, 2 years down the line, because of the available weather stations data itself. My first, as an IPP, and Panama Wind Energy has always been a well thought process was there, and we've always wanted that whatever we produce as a commodity, whether it's electricity, the customer who is the distribution company should be able to understand what I'm going to produce, at what quality I'm going to produce, at what rate I'm going to produce. So when the first regulator started asking us to why don't you start your own examples and try to stand and estimate what's your forecast. Without any compulsions from the regulator, we were the first to appoint certain consultants at the site and try to understand whether at what rate or what accuracy my forecast will be. And that was 2012-13 when my project got commissioned. I appointed certain consultants and they started doing the forecasting as per the requirement of the regulator, which was stipulated at that point of time. But over a period of time, and then itself order had a certain legal problems which the entire order was not implemented. Panama started continuing its studies because I knew that at some point of time, in order that the country wants to basically increase the penetration of renewables, increase the penetration of wind into the grid, it has to forecast. It has to tell the load dispatch center that I'm going to pump in so much of electricity in next 3 hours, in next 8 hours. So I started continuing my experiments. I deployed some other consultant. They started doing their own exercises, because normally these consultants use and deploy some of the other European well-known established consultants to get the weather data. They hire some stations, weather stations, to get the data, and they start doing their own algorithms and they start forecasting. I continue to do that. I kept on giving my entire output data to the regulator and the SLDC, that is State Lustrate Dispatch Center, that this is what I am producing. But at the end, when regulator also started evaluating, and at some point of time, the regulator, that the CRC, the Central Electricity Regulator, came with a redefined approach. It's, I think, 4 months before they came up with a new set of regulations. At that point of time, GE India, who is one of the largest wind turbine developer and wind turbine manufacturer, and has a huge lot of experience across the continents, came into an agreement with us that it's our machine. We have this 72 megawatt Satara, which you're seeing, has GE turbines of 45 machines of GE make. It's a 1.6 82.5 meter rotor machine. So they came up with their Predix platforms, telling that we have come up with a digital platform idea, that we have our own algorithms. It's our machine. We know the site much better. We know how the machine is going to perform. The wind data is there with us. We will develop algorithms and try to forecast the data as per the requirements of CRC. So we started with an experimentation. Since last April, we have started doing this. Team members of GE came to the site. We had some hardware modifications, and then we started doing our own exercises and trying to see how fit within that bracket are we. And I am proud to say that after using the GE algorithm and the GE Predix platform, 94% of the energy that was produced over the year till date was within the no penalty band. That means I am as close as 94% of energy that I produced out of the wind farm was as per the predictions that the GE algorithm was able to give it. So that's itself a huge achievement that I can call, with the partnership with GE and Panama together, and the amount of resources that have been put on the site, we will be able to achieve this. One of the foremost challenges is that these sites are very remote. Even to go from the access roads are remote. It's a huge rainfalls at some point of time. To put up our own leased lines was an issue. We started hunting the one who can actually give us the digital connectivity to that site. And after a huge follow-up with BSNL, we ultimately got a 2 Mbps line. So that was the first hindrance that we got, that the connectivity is not very healthy there. So you have to depend on data. So what happens is that we then deployed a local server there. We had GE has their own servers somewhere else in the globe. So all these servers were then able to communicate with the lines. Then accessibility sometimes of going to the hardware site there, going to the sites in terms of weathers are very adverse. So these are the limitations that these sites have, and foremost limitation was the connectivity to the site, digital connectivity to the site. When you're sitting in control rooms, you have to know it's a generating station. It's 100 megawatt of energy generated. So you have to be close to the asset. Now, how can you be close to the asset? By not being in front of asset is just industrial internet. So there are 4 basic important phenomena that these provide. One is visualization. You are able to visualize your wind farms without really visiting the wind farm. That gives it's an online visualization. Then you are able to optimize the performances. You are able to analyze the data. So visualization, optimization, asset management, and basically analytics. Analytics plays a huge role in industrial internet, and therefore I feel this digital platform, whether it's G based or the platform that G is giving, or some others are also in giving in this race, is playing a huge role. What it will do, it is going to increase or power up the production that is going to be generated of the wind. We are generating power from a resource, which is wind. It's not in our control. But what is in our control is the asset that is converting this wind energy into electrical energy. Now, if you're able to play with this asset to the efficient version, or if you can reduce the downtime, or you can increase the uptime, you are able to go closer to the machine, you are able to reset the fault sitting isolately. Each and every data that the machine generates is able to be analyzed by sitting through these digital platforms. Definitely there will be a power up of the available from the same asset which was generating say X. There is always a possibility that this X will go to Y because of this digital internet.